Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Hope everybody is okay. I'm just having a quick look through the chat. Hi, Kev. Hi, Pauline. Stuart, and many others. Okay, so, well, what have we got for you tonight then? So tonight we are going to be looking at the latest findings from Saturn's moon Titan. There have been a number of discoveries and observations made recently, which again have changed our view a little bit of this enigmatic world in the outer solar system. So we're going to be having a delve into Titan, as it were. We're also going to be having a look at Dragonfly, which is NASA's mission to Titan, launching in 2028 and arriving in 2034 if all goes well. And that's a most fascinating mission. That we'll tell you all about that a bit later. So joining me this evening, I've got Roger. Hi, Roger.
Good evening.
Good evening. Michael, how are you? Feeling better?
Yes, thank you.
Good. Lou, how are you?
I am well. Greetings from abroad.
Abroad. Fantastic.
Wait, I didn't say that right. Okay. Never mind.
You've got a one-track mind, Lou. You
I
really...
help.
Yeah. Anyway, moving on. I'm delighted to welcome Dr. Dave Williams as our newest member of the Space Oddities team. I hope you'll make him all feel welcome. Dave, you're more than welcome, and we're really happy to have you along for the ride. So, just as
it were.
Yeah.
Thank you. Thanks. I'm really happy to be here. And so Lou's in Maryland right now. I'm in California, so we're spanning a good part of the globe. I guess that's not bad.
Oh yeah,
that's not bad, is it? Whereabouts in California?
Just a little bit northwest of Los Angeles.
Wow.
It's Moore Park. I don't know if you know California, like near Thousand Oaks, Simi Valley area.
Never heard of it. So,
Yeah.
So no, I know where Thousand Oaks is. So there you are. Great. Well, you're more than welcome. And viewers, if you have any questions for Dave, I'm sure he'll be more than happy to answer them. Dave like Lou, is a planetary scientist. Do you have any speciality in planets, Dave?
Well, I mean, I did my PhD and some of my research early on Venus, but once I started working at the data center, once I started working at the data center at NASA, it's sort of every mission that flies now I was involved with. So I ended up basically getting, a smattering of stuff from every planet, really.
Fantastic. What a lovely job to have. So jealous.
It was.
Yeah, jealous of you planetary guys. So they were, and Lou's speciality is, of course, Titan. That's his field of expertise.
Tis.
So
because it has an atmosphere, not just a boring surface that sits there.
No, that's right. And also a very thick atmosphere, not just any old atmosphere.
That's right.
Thick one. So there we are. Okay, so we'll get onto those things later. As usual, viewers, you are all welcome too. Of course you are. So good to see so many of you here. Shelley, hi, I hope you're well. And Jerry's here now. Sandra, hi, Sandra, I hope you're well. And I hope you're still sea starring, weather permitting, obviously. And of course, if you would like to support Space Oddities, you can do so in one of a few ways. One thing that you can do is to keep us going in caffeine. So we accept all donations for caffeine. And if you would like to buy us a coffee, you can do so by either scanning this QR code or clicking the link that's just appeared in the chat. And that'll take you to the Buy Us a Coffee page, because astronomers' lives matter, where you can buy us a coffee for a paltry amount. And of course, you can also go to the Space Oddities shop and buy your Space Oddities t-shirt and hoodies there. Be the first on your block to adorn yourself with this fantastic merchandise. And everything you need to know is there. And you can again scan the QR code or click the link that's just appeared in the chat. Don't forget, we also have our Patreon page, where just for a few pounds every month, you get access to all our presentations, videos, all sorts of other stuff, and it's well worth doing. And that's a very, very simple address. It's patreon.com/Space Oddities. So join our Patreon community, and every bit of money we receive goes straight into keeping the channel going. And that's it, because we have bills to pay like everybody else. So help us to support the channel. Help us to carry on bringing you the quality science journalism that we give you every week. No bullshit, no clickbait, just the facts. And if you'd like to support that effort to keep science, then please do support us, and your help is much appreciated. Okay, so also tonight we have the regular features. Roger's going to be doing the night sky in the gallery. We have Constellation of the Week, which I think is a bit bigger this week than it was last week. And yeah, Roger's smiling wryly to himself. And we also have Einstein of the Week, our weekly delve into the nether regions of social media. So there we are. That's what we've got coming up for you. So let's get the show on the road. So I think the first thing we're going to do this evening is to have a look at the news. Just a few things in the news this week that caught my attention that I thought you might like to know about. So just give me 1 second, and we will get straight onto the news for this week. So here we are. There we are. This is the news, therefore, for the 18th of November. The first thing comes out of the test images, if you like, that were released in July from the Vera Rubin telescope, and this is one of them. So this is, as I said, one of the first released images from the Vera Rubin telescope. It's from their LSST, which is the Legacy Survey of Space and Time. And it's revealed an exceptionally faint and remarkably long stellar structure trailing the nearby galaxy M61. Astrophotographers, have you done M61? Anybody? Mike?
I don't
Roger?
think I have.
Probably, yes.
Probably. Well,
Yeah.
this is this feature. It's got a really, as you can see, it's got a really low surface brightness. And this is a stellar stream. It's literally, if you like, a river of stars stretching about 50 kiloparsecs, or about 163 light years away from M61. In fact, it's comparable in length to the whole size of the Milky Way itself. It had remained invisible in previous surveys because it's far dimmer than the sky background and requires exactly the deep, wide, sensitive imaging that Vera Rubin's designed to deliver. Now, astronomers believe the stream represents the remnants of a dwarf galaxy that was gradually torn apart by M61's gravitational field. As this smaller dwarf galaxy orbited and interacted with M61, its stars were stripped away and stretched into this sort of long, tenuous ribbon. Discoveries like this provide direct evidence of the hierarchical process by which large galaxies grow, that is, through repeated mergers and slow consumption of smaller companions. The image demonstrates Rubin's ability to uncover structures that were beyond the reach of earlier instruments. This is why the Rubin telescope is going to be so revolutionary. It will be able to see things that previous sky surveys didn't. Now, it's due to begin full operations very soon, I think. I thought it was meant to be October, but it hasn't started yet. But very, very soon, it's going to start its revolutionary sky survey of the Southern Hemisphere, where it will be photographing the southern sky every 3 nights in its entirety. And obviously, we expect more hidden gems like this one. And we will obviously bring you news and images from the Vera Rubin telescope when it gets operational. And this should transform our understanding of exactly how galaxies develop, grow, evolve over cosmic time. So this was actually an amazing image. Now, if you are interested in helping out the Vera Rubin team, if you go to zooniverse.org, there are 2 citizen science projects you can get involved with involving the Vera Rubin. One of them is the Rubin Comet Search, which is searching for comets in these initial test images from Vera Rubin that were released in July. And then the other one is a new one to help them to verify the alert system. So basically what the telescope is going to do, it's going to photograph the southern hemisphere sky in its entirety every 3 nights. And this means that it will be able to see very easily anything that has changed since it photographed that bit of sky previously. Now, this involves the creation of an alert system. So if anything has changed in the night sky, anything from a supernova to the passage of an asteroid or anything that changes or moves, the telescope will generate an automatic email alert to astronomers all around the world. It's estimated to be generating, once it gets into operation, get this, 2 million emails per night. And
almost as many as I get. Jeez.
Now, they're setting up an alert system, and anybody will be able to receive those alerts, anybody. But obviously, nobody wants 2 million emails a night flooding through their inbox. So you'll be able to filter exactly what type of alerts you receive. They want to test that this alert system is actually putting out genuine alerts, and the software isn't making mistakes in misidentifying things. So at zooniverse.org, there's a project now where you can help them to verify the system, to teach the system what is a real alert or what is a real event and what isn't. So head over to zooniverse.org if you would like, as a citizen, to get involved with that and help out the astronomers. So moving on, we go to the solar system. And this was a bit of a strange discovery, because recent studies revealed that our solar system is moving through space at more than 3 times the speed previously estimated. Researchers analyzed the distribution of distant radio galaxies using a large radio telescope network and discovered an unexpected headwind effect, if you like. There are more radio sources that appear ahead of our motion around the galaxy than behind it. This signals a faster relative speed that the solar system is moving at. The measured anisotropy, or dipole, in these radio galaxy counts is about 3 times 7 times stronger than the predictions of the standard cosmological model. And this has got a statistical significance exceeding 5 sigma. In other words, it's a definite phenomenon. So this finding challenges fundamental assumptions about cosmic uniformity and the motion of matter at large scales. Either our solar system is racing faster than anticipated around the galaxy, or the distribution of radio galaxies isn't as uniform as the cosmological principle suggests. In either case, the result points to a need for re-examination of models underpinning large-scale structure and motion in the universe. So this was a bit unexpected. And because I thought, well, astronomers thought this was all worked out. We knew what speed the solar system was moving around the galaxy. But now it appears it's 3.7 times faster, which is a bit of a difference. So we'll keep an eye on this one.
I mean, it's either fascinating or impossible. If we're moving tangentially, okay, maybe we're not. Well, if we're moving tangentially, and we know the mass of the galaxy to some precision, then it's very easy to find the distance with which our velocity ought to be, the radius of the orbit.
Yeah.
So perhaps we don't know our distance as well, or perhaps we're not moving tangentially around, or more than likely, MOND is rearing its head, I think.
Yeah. Well, I'm going to have to say no to that one, unfortunately. But the fact that this has got a sigma 5.3 means that whatever is being measured, it's a real phenomenon. What is it? Less than 1 in 10 million chance that it's not a real phenomenon. We'll keep our eyes on this and see what happens. obviously, it's just one team who have discovered this, and it needs to be borne out by other teams to make sure this is actually real. So interesting finding on Earth. Something's not right. As it says, either the distribution of radio galaxies isn't what it should be according to the cosmological principle, which basically says the universe should look the same everywhere, or there's something else going on. So interesting. Okay, so have to sadly report the death of a comet, not that one. This, in fact, is comet C25 2025 K1 Atlas, and it's broken apart following its close passage around the sun, where it came within 49 kilometers of the sun. During the night of November the 11th and 12th, the nucleus fragmented into at least 2 large pieces, as you can see here, each roughly the same size, and they're about 2,000 kilometers apart, those 2 pieces, and smaller fragments as well. This is a comet new to the inner solar system. It's an Oort cloud comet. It's come from the outer Oort cloud, and likely on an open trajectory, which means it will depart rather than return. Its sudden disruption is scientifically valuable because it gives insight into the internal structure of a pristine comet before multiple perihelion passages. The breakup also impacts its upcoming closest approach to Earth, that is to say around 60 million kilometers from the Earth on November the 24th, potentially reducing its brightness or altering its appearance. But obviously it's going to be a great object of study when it comes closer to the Earth. And, we've seen comets do this time and time again. They break up due to getting too close to the sun, and, it won't be the last time. But of course, the whole internet is saying this is Comet 3I Atlas, the interstellar comet that's what, as people kept saying, exploded. I kept trying to point out to people, no, comets don't explode, they fragment. But anyway, this is all valuable scientific information in our study of comets. Well, next we go to exoplanets, and a newly identified Earth-sized exoplanet designated TOI 2431b orbits its host star in just, guess how long? 5 hours 22 minutes. Making it one of the shortest period planets known. It's got a radius about 1.5 times that of the Earth and around 6.2 Earth masses. And its high density suggests it may once have been larger, but it's been stripped down by intense stellar radiation. One side of the planet is likely perpetually facing its star. In other words, it's tidally locked, and its surface temperature exceeds 2000 Kelvin, which means it's probably a sort of a lava world. It's under extreme tidal stress, not surprisingly, as it spirals inwards. Its current orbit lies only 30% or roughly 30% above the critical Roche limit period, and models estimate its remaining lifetime about 31 million years. So it's still got 31 million years before it crashes into its star. Its host star is relatively bright, though, giving the system a high emission spectroscopy metric, which makes it a strong candidate for atmospheric or phase curve follow-up observations. Though inhospitable, TOI 2431b provides an observational laboratory for extreme planetary physics and the final stages of planetary system evolution. So 5 hours whizzing around that star. That is quite shocking, really.
Did it say what kind of star? What spectral?
No, I haven't got that information available. I don't think I can look it up though. I'll look that up and tell you later.
Okay.
It has actually stated how far it is from the star either, but it's obviously 5 hours. It's going to be really close to the star. So there we are. So interesting there. Okay, I'd like to thank Roger and Michael for, oh no, Roger wasn't there, it was Daz. Anyway, I'd like to thank a couple of Space Oddities people for joining me when we covered the launch of Blue Origin's New Glenn live. And it was an amazing mission. Beautiful photograph there showing the Mac diamonds, as they're called, in the exhaust plume. Fantastic launch. And this was an amazing mission because not only did it launch NASA's twin Escapade spacecraft on their way to Mars, well, on their way to Mars via L2, as I was saying last week. But also, it was their second attempt at landing the first stage back on a barge in the middle of the sea. And well, I'm going to show you what happened now. If you just give me a second, because this was quite amazing. So what happened was that we were watching the view from the first stage. They had a camera mounted on the bottom of the first stage, looking down at the sea. And as it got closer and closer to the sea, there was no barge underneath it. And we were saying, it's going to miss, it's going to miss. But it didn't, because it was not designed to go down vertically onto the barge. They actually were aiming for a point 30 meters away from the barge, making sure that they had the engine under full control, hovering it before they made a decision as to whether to land on the barge or not. And when they saw that everything was good, it sort of slipped sideways onto the barge and made a perfect landing. And here is the film of exactly this. And they just sort of hang it there for a while, checking everything is okay. And then, yeah, that's absolutely fine. And they just bring it in slowly, and it landed at a speed of about 1 meter per second. Perfect landing.
That's amazing.
But there was more to follow. I hope you show it.
Like deployed.
Here's the view from the first stage.
Great shot from our booster.
Standing back for touchdown.
Oh,
Standing back for touchdown.
Absolutely amazing. Now watch the end of the landing legs. This is what you could watch. See those small explosions? Those small explosions. Yeah. At the end of the landing leg, there were small explosions. And this was amazing. We weren't expecting this at all. Blue Origin have patented a system where small explosive charges go off at the end of the landing legs, driving tungsten carbide pins into the deck of the drone ship,
yeah.
Whoa.
forming a weld which completely secures it to the deck without the need for any extra equipment.
That's amazing, isn't it? That.
Yeah, it is. So there we are. Just give me 1 second. Sorry.
What if they want to take off again? That's going to be a problem.
Have to refurbish it and go back to the launch
Isn't
site.
that the whole idea of refurbishing?
Yeah. So it was an amazing mission. Blue Origin thus joined the club of companies able to land boosters,
Yeah.
to reuse them. That club, of course, has only had one member up until now, and that's SpaceX. So there are now 2 companies in the club of reusable first stages. So well done, Blue Origin. You know, they've come under a lot of flack in the past, especially from us here, but they did a fantastic job. And the best thing is that NASA's Escapade spacecraft are now on their way to Mars, where, as I was saying last week, they'll be studying the Martian magnetosphere, essentially, and trying to work out what happened to Mars' atmosphere all those billions of years ago, why and how it escaped into space. So the twin Escapade spacecraft will be going, first of all, out to L2, nearly a million miles beyond the Earth, away from the sun. They'll stay there for 11 months where they'll be monitoring space weather. And then when the 2 planets are in the right position, they will come back to the Earth, get a gravity assist around the Earth, and swing out to Mars, arriving another 11 months later, because they're 2 very cheap spacecraft and they only have low power thrusters. So it's going to take them 11 months to get from the Earth to Mars, where they will start science operations sometime in 2027. So there we are. So a good result all around. Everybody wins. Everyone a winner. So
Actually, just a quick question in the chat.
yes.
Where has it gone? Where's it gone? Why is it not doing that? There it is.
What is Andy's cat's name?
Which one? Sorry.
All of them.
Okay. Well, the one. What is Andy's cat's name? Right. So the one. Hang on. There's another one just popped up here. This is this is April. She's only got one eye, unfortunately. But
Oh,
she lost, and we don't know how she lost the other one. She just came in one day with her eyeball hanging out. I don't know what happened, but they couldn't save it. So she's only got one eye. But she's about 6 years old. And then sitting behind me, we have Violetta. This is Violetta. She was a feral cat, but I've domesticated her, and now she wouldn't be anywhere else. And she did have a brother called Putin, but he disappeared. He just wandered off one day, never came back. But there we are. We've got another two cats somewhere. So there we are. So now we know. That was April and Violetta. Okay, so let's move on then. And we hope you've all had a good week, by the way, viewers. And we're so happy that you're here tonight sharing our Tuesday evening with us. What we're going to do now is to get down to the meaty stuff of the evening, because there have been a few discoveries about Saturn's moon Triton recently, and who better to ask about them than a planetary scientist who specializes in Triton. By the way, that's you, Lou.
I'm on.
Yeah.
Okay. Ready. I'm ready.
So there we are.
Couldn't imagine.
So here we are. So let's listen to Uncle Lou.
Uncle Lou. Well, you heard it here first. Well, I thought about just starting with a question. What is the most interesting, exciting object in the entire solar system worthy of our worship and our reverence and respect? And of course, the answer
Pluto
is Pluto. But we're going to talk about Titan today. They're a fascinating world that just continues to beg our exploration. And so we've been exploring Titan now for quite a while, since Christian Huygens discovered it, but more recently. And I don't see, by the way, Andy, I don't seem to see arrows to change my. Let's see.
know.
Right, hold on, let's see. There they are. Okay, very good. All right, so just a little primer on Titan before we get to the latest research. Titan is the only moon in the solar system to have a substantial atmosphere, and it's the only body in the solar system, other than Earth, to have liquid flowing on its surface. So that makes it interesting right off the bat. Ever since Gerard Kuiper detected methane in Titan's atmosphere from ground-based spectroscopy, that was back in 1944, astronomers have wanted to know more about this perhaps most Earth-like of solar system bodies. And so I'm really kind of campaigning. We say that Venus is our sister planet. I think Venus is a hellhole, and I'm just campaigning for Titan to be our sister planet. So we'll see if you agree with me when we're through here.
Well, I certainly think the two have got a hell of a lot more in common than we have with Venus.
I agree. I agree with you, Andy. That's why I'm putting my heart and soul into these presentations. So Titan is larger than our moon. In fact, it's larger than Mercury. If it wasn't orbiting Saturn, it would clearly be a planet. It has seasons, it has clouds, it has rain, rivers, lakes, it even has seas, but all of this at somewhat lowly temperature of 95 degrees Kelvin at the surface. And 70 degrees Kelvin at the tropopause, where the temperature turns over in the atmosphere. So for everyone else, this is about minus 178 to minus 203 degrees centigrade. So pretty darn cold. Water is frozen out like steel on the surface. But so let's take a look at some of the interesting research findings of this strange but tantalizing world. And let's see, there we go. I have to hit 2 buttons in order to advance my slides. I see that. All right, we'll have to get to that. Well, one of the things that makes Titan so fascinating is its atmosphere. As we've said, its atmospheric chemistry is a complex system of that's primarily driven by the breakdown and recombination of nitrogen and methane in its atmosphere due to solar ultraviolet light and energetic particles from Saturn's magnetosphere. The photochemistry is about 90% of the evolution of the atmosphere, and the particle chemistry maybe about 10%. So this process generates a wide range, an enormous range of organic molecules or hydrocarbons, as well as nitrogen-containing molecules or nitriles, which form the moon's characteristic thick orange haze. That's why we can't see to the surface in visible wavelengths. And these are long chain polymers, kind of like smog in LA in the summertime. Okay, very thick. The main atmospheric constituent is nitrogen. So what do we know about Earth, right? Our primary atmospheric constituent is nitrogen. 94% for Titan, methane about 5.5%, and various trace amounts of other gases, hydrocarbons, hydrogen-bearing fuels, argon, and just various other organic compounds. The energy input, in other words, the UV radiation and the electron impact from the magnetosphere of Saturn, occurs primarily in the upper atmosphere, and this breaks apart the nitrogen, the N2 and the CH4, into all these reactive radicals, as we said. And these radicals quickly react with other species to form more complex molecules. Everything from diacetylene to dicyanoacetylene to hydrogen cyanide and everything else you can imagine. It's really quite a well-populated chemical soup. A significant outcome of this chemistry is the formation of solid organic aerosols. These are called tholins. I think this was a term that Carl Sagan first coined when he was doing experiments in the laboratory to try to simulate Titan's atmosphere, and it produced this kind of orange gunk on the inside of the flasks that he was using. And I think tholins comes from the Greek. It means kind of or dense or foggy. Many of the produced hydrocarbons, such as ethane and acetylene, condense in the cold atmosphere and fall to the surface as rain, forming rivers, lakes, and seas of liquid hydrocarbons, not water, but hydrocarbons. Methane is also part of the cycle, the primary part of it in the troposphere. And similar to Earth's water cycle, it condenses into clouds and precipitates down as rain gathers in pools and evaporates again. So there's a methane cycle on Titan as opposed to a water cycle on Earth. So pretty cool stuff. Let's see, 2 buttons. 1, 2, there we go. So some of the latest research on Titan. Turns out that Titan is challenging one of chemistry's oldest rules, that like dissolves like, by showing that incompatible polar and nonpolar molecules, these are molecules that either have electrons unevenly distributed or evenly distributed around them, can combine under its extreme cold temperatures. Scientists discovered that hydrogen cyanide, which is a polar, forms stable co-crystals with hydrocarbons like methane and ethane, which are nonpolar, on Titan's frigid surface, a phenomenon not seen in Earth's warmer environment. And this finding has implications for how life's building blocks could possibly form in extraterrestrial environments. That's kind of interesting.
Yeah.
Yeah. Let's hear it for Titan. Next slide. Okay. There's some new research regarding the surface of Titan. New research is finding that despite large rivers and seas of liquid methane and other hydrocarbons and a few nitriles that precipitate out in the lower stratosphere, Saturn's moon Titan seems mostly devoid of river deltas, raising new questions about how the surface dynamics on this alien world work. A research study out of Brown University in Providence, Rhode Island, had scientists wanting to learn about the geological history of planets. River deltas are a great place to start. So deltas gather sediments from a large area into one place. This would be very important, by the way, for observations and research of Mars. These sediments can be studied to reveal climate and tectonic histories or signs of past life. That's why NASA has the Perseverance rover in Jezero Crater right now, which is home to a prominent and well-preserved delta. And that's also why planetary scientists, including Dave, are interested in finding deltas on Titan. Titan is the only planet, only body in the solar system, as we said, besides Earth, that has liquid water currently flowing across its surface. So its deltas could be a scientific treasure trove. But there is one problem. Titan appears to be largely devoid of deltas. A new study by Birch et al., published in JGR Planets, finds despite its large rivers of liquid methane and ethane, as measured from Cassini SAR instrument, the synthetic aperture radar, the researchers developed a numerical model to simulate Earth's coastlines as they would appear in Cassini SAR images. They show that multi-kilometer scale landforms are detectable on Titan, and provided there is sufficient contrast between the land surface and seafloor. And so they revisited the Titan data sets and show that many of its large coastal rivers do not, in fact, terminate in deltas, in contrast to Earth. So it's unclear exactly what this means at present, but it's an interesting finding. All right. There we go. So, cryovolcanism, and let's see, Andy, are you going to talk about cryovolcanism on Titan?
No, I'll leave that to you.
Okay, all right, fine. So we've suspected that Titan may have cryovolcanoes for some time. And the Cassini mission has collected data from several previous flybys of the moon that suggest their existence. Imagery of the moon has included a suspect haze hovering over flow-like surface formations that some point to as signs of possible cryovolcanism. Such volcanism could release methane from the interior. This is important because we see large reservoirs of methane in the troposphere of Titan, and it really shouldn't be there because it breaks up very easily. It's a very delicate volatile, so perhaps it's getting replenished. So this volcanoes or cryovolcanoes could continuously supply fresh methane. Without replenishment, scientists say Titan's original atmospheric methane should have been exhausted a long time ago. This is true, by the way, in our studies of Mars methane. It shouldn't be there, and we're looking for reasons that it might be there. One possibility is microbes below the surface. But for Titan, here we can see, here in these three pictures, we can see a change in surface features detected on Titan from the three composite images. These were taken during flybys by Cassini in October of 2005, January 2006, and March of 2006. I think this is from the VIMS instrument, the Visual and Infrared Mapping Spectrometer. So these three images of the same area in western Xanadu show a difference in brightness, right? And a difference in color.
Very clear.
That has occurred. Yeah, so something is changing the surface during these approximately, 5 or 6 months or so between first and second images shown here. This is indicative of compositional change and is interpreted by some as evidence of eruptions of volatiles such as water, ammonia, and methane. So perhaps this solves the ancient question of why they're called apartments when they're all stuck together, and why Titan has continual methane.
Amazing.
And I know we're going to have a dragonfly talk in a bit, so I'll just keep this slide short. There's a new mission planned and in development at the Johns Hopkins Applied Physics Laboratory to go to Titan. It's called Dragonfly. It is a 4-rotor copter that is scheduled to launch in 2028 and arrive in 2034. And I'm just going to leave it at that because I know we're going to hear a lot more about this. And I think I skipped a slide.
Yeah,
Either that or okay.
Yeah.
Let me see if I can go back. Oh, there we go. That's what I was expecting. Okay. All right. Possibilities for life. This is why we're interested in Titan, because it's so Earth-like, prebiotic atmosphere, and could it have life? And in a recent paper that was published by Cambridge University Press by Christian Mayer and Connor Nixon, who was at Goddard Space Flight Center for quite a while and is a very tenured Titan explorer. Paper entitled A Proposed Mechanism for the Formation of Protocell-like Structures on Titan. The authors propose a mechanism for the natural formation of vesicles in Titan's hydrocarbon lakes. These vesicles form the complex chemistry in Titan's atmosphere, containing a wide variety of complex organic molecules, hydrocarbons, nitriles we've already identified, that are generated by photodisassociation of methane and nitrogen in the upper atmosphere by ultraviolet sunlight. And then these particles, these aerosol particles that are created are, I think they're submicron size, and they kind of very slowly diffuse downward onto the surface, including hydrocarbon lakes. And as they diffuse downward, by the way, they're acting as nucleation centers that pull gases out of the atmosphere depending on the pressure and temperature at that altitude. And so these little particles, these little submicron particles, act as kind of like a glass of cold ice water on a hot summer day. You see water coming out of the atmosphere, glomping onto your glass and making it wet. And that's the kind of thing that's happening as these aerosols diffuse downward. According to the authors, these vesicles could form cell membranes that encapsulate liquid and could be fairly stable. In fact, different populations of membranes could compete. I just found this fascinating, initiating a long-term evolution process that could eventually result in primitive protocells. Wouldn't that be something? Protocells on Titan. I challenge any of you to come up with anything cooler than that today.
I find it just absolutely incomprehensible that all this can happen in such low temperatures. It's amazing.
It is, and yet it is. We know on Earth, the more we explore the Earth, the more that we find these extremophiles in very harsh environments. So maybe it's, I've used this analogy before, anyone who's seen a weed or a flower growing out of a crack in a sidewalk, you know that life wants to exist. So maybe it just finds a way in these really environments that we couldn't survive in. We will see.
Yeah, and the Dragonfly mission is going to be exceptionally interesting. So there we are. So, well, anyway, Lou, thank you so much.
Sure.
And what we'll do now, we will actually move on. Just give me a second to talk about the NASA Dragonfly mission to Titan, which, as Lou said, is in development. So just give me 1 second. And we will move there absolutely right now. So this is NASA's Dragonfly mission to Titan, and it's going to launch in a few years. So let me just get to where I need to be, and I'll tell you all about it. So let's look at the background of it. This is a bold new frontier for planetary science. It's the fourth in NASA's New Frontiers missions. It was selected in 2019 after a rigorous competitive process to push the boundaries of planetary exploration. Now, the launch is planned for July 2028, so in about 3 years, give or take, just under 3 years, aboard a SpaceX Falcon Heavy rocket from Kennedy Space Center. So SpaceX have got the job of launching it. And it will arrive at Titan 6 years later in 2034, where it will become the first rotorcraft to fly on an outer solar system moon. And it represents humanity's most ambitious atmospheric exploration mission yet. Now, the scientific objectives for the mission can be broken down into 4 categories. The first one is prebiotic chemistry, as Lou was talking about. And the objective is to investigate the complex organic chemistry and assess Titan's potential for microbial habitability in its unique environment. Secondly, surface exploration. And Dragonfly will explore diverse environments to understand how organic chemistry progresses from simple to complex molecules. Thirdly, the search for chemical biosignatures that could hint at past or present life forms. And lastly, Dragonfly will study the intricate interactions between Titan's nitrogen-methane atmosphere, organic-rich surface, and subsurface ocean. So those are the 4 categories of mission objectives that the Dragonfly, if all goes well, will perform. This is an engineering marvel. Let's have a look at the Dragonfly itself. Well, it's a rotorcraft. It's got 8 rotors, providing redundancy and stability. It's approximately the size of a small car. It's got a mass of about 450 kilograms. The power source, as it is with the all outer solar system spacecraft, it's going to use a radioisotope thermoelectric generator, which generates electricity from the heat of decaying plutonium, providing approximately 70 watts of continuous power. Dragonfly is capable of vertical takeoff and landing, with flights up to 8 kilometers per sortie across Titan's surface, exploiting Titan's dense atmosphere, which is 4 times the density of the Earth's, and its low gravity, which is 1/7 of the Earth's, for remarkably efficient flight. This baby should really fly well in this atmosphere. It's been designed specifically to do so. So what instruments does Dragonfly carry? Well, first of all, the Dragonfly mass spectrometer, not surprisingly known as DRAMs or DRAMs. It's going to analyze organic molecules in surface samples, identifying complex chemical compounds that could be precursors to life. It also carries a gamma ray and neutron spectrometer to determine the elemental composition of the surface, mapping the distribution of key elements. DragMet is a geophysics and meteorology package to study Titan's atmospheric conditions, weather patterns, and surface physical properties. And lastly, DragonCam, well, you'll no doubt know what that does. Not just one camera, but it's a suite of high-resolution cameras to provide detailed geological context, enable precise navigation, and capture stunning imagery, we hope, of Titan's landscapes. Now, I've tried to find out what resolution the cameras have, but that information doesn't seem to be available. So when it says high definition, we don't know exactly how high definition, but whatever they are, we're going to get some stunning views of those really strange, bizarre landscapes of Titan. Where's it going to land? Well, Dragonfly will land in the Shangri-La equatorial dune fields, because Titan's got dune fields that go on for forever. And this is a bit like Earth's Namib desert, offering insights into Titan's organic sediment transport. One of its main targets is what you see here now. This is Selk Crater. It's a 90-kilometer wide impact crater with evidence of past liquid water mixing with organics, creating an ancient prebiotic soup environment rich in astrobiological potential. Selk Crater offers extraordinary clues to the chemical pathways that could lead to life, making it a prime target for investigation. Now, the journey to Titan, well, as I said, it's going to launch on a SpaceX Falcon Heavy rocket in July 2028. It's going to cruise for 6 years through the solar system, using gravity assists for optimizing its trajectory, as you might expect. Arrival in 2034, descending through that thick nitrogen-methane atmosphere, and the surface operations then will commence and there is a 1 hour communication lag between Titan and the Earth. And as far as the mission timeline and operations go, well, it's going to explore for 3.3 years. That's the designed initial primary mission, and that will carry out the research that we've talked about. But it's not uncommon to find these missions being given an extended science phase. So if all goes well, it might be extended beyond the 3.3 years. So that will end in what, 2037. It's in total, it's going to travel 175 kilometers around Titan. That's nearly double all Mars rover travel combined. So long distance travel on Titan. And it's going to make one flight approximately every 1 to 2 Titan days. And by the way, each day on Titan lasts 16 Earth days. So so there we are. So it's going to do a lot of traveling around Titan. Unfortunately, and a bit sadly, it's not going to go anywhere near these lakes of liquid hydrocarbons that Lou talked about. But one hopes there will be a follow-up mission at some point. Although I don't suppose I will live to see it. But anyway, a lot of traveling around Titan, collecting lots of data. Now we can then ask the question, well, why does Dragonfly matter? Well, it advances rotorcraft technology for future planetary exploration missions, because we know from Mars that we can fly vehicles in planetary and moon atmosphere. And Titan serves as a pristine laboratory for studying Earth-like prebiotic chemistry without biological contamination, offering a unique window into the early conditions that led to life. The Dragonfly mission is a unique opportunity to determine if life's origins follow universal chemical pathways or if Earth's evolutionary history represents a unique cosmic accident. So if we can see the same sort of processes happening on Titan with the beginnings of life that we think happened on the Earth, then it may well be universal, that this may be how life gets started, not necessarily in all places in the universe, but certainly in some of them, or maybe even most of them. Now, all of this could fundamentally revolutionize our understanding of habitability, organic chemistry, and the potential distribution of life throughout the cosmos. So really, Dragonfly matters because, yes, it's a mission to explore an alien moon, and that's great. But the real crux of the mission is to study perhaps the conditions that led to life on the Earth and Titan, that we might apply these to other worlds in the solar system at least. So it's going to be a very, very important mission. And of course, we'll cover it on Space Oddities for you. And it's you know, it's still a bit depressing to think that the landing is still 9 years away, but it's going to happen. So there we are. Dragonfly has undergone several budgetary reviews and looked at one point under the current administration as if it might be cancelled, but it seems to be going forward. So all fingers crossed for a launch in 2028. And of course, we hope to be here to cover all that for you. So there we are. I just want to go, there was a question there that we had, I think from Sandra about Titan. Here we are, Lou, here's one for you. Sandra says, do you think Titan was on its way to being a planet?
Well, I guess it depends on what you mean by on its way. It has everything you would need for being a planet, except that it's orbiting Saturn. Now, one other possibility, its density is quite low. It's about 1.8, 1.9 grams per cubic centimeter. And that means there's an awful lot of water ice and not nearly as much rock, right? So it doesn't, as is demonstrated by its gravity that you were talking about, Andy. So the question would be, if it was orbiting the sun instead of Saturn, could it clear out its orbit? Which is the third requirement from the, I don't know, whatever the organization is that that decides.
The International Astronomical Union.
Thank you, the IAU, right. So, but otherwise, why not? It's got everything else.
Yeah. And, you know, I'd agree with you. I think at the moment, for me, the four most interesting worlds in the solar system have got to be Pluto, Titan, Europa, and Enceladus. And I think, although obviously Uranus and Neptune are due for a revisit as well.
Not Mars?
No, not really.
You're tired of Mars.
I'm a bit bored with Mars, to be honest. Nothing ever seems to happen. We never seem to get anywhere with Mars. But
Hey, when Mars attacks again, you're not gonna be ready.
oh no, absolutely, I agree with you. But we will be talking about the inhabitants of Mars a little later this evening, when we get to Einstein of the week. So there we are. No, of course they're all interesting, and they all have their particular aspects that are fascinating and different and worthy of study. But I find Titan particularly fascinating because it is a bit of an oddball, isn't it? It's not what you would expect from a moon of Saturn, and there are no other moon of Saturn remotely like it. So in that sense, it's extremely unusual. And you know, one thing that Cassini showed us, that those moons of Saturn, really bizarre places like Enceladus with its geysers or geysers, I think you transatlantic people say. And but the rest of the moons were not that revelatory, if you like. But I think you know, Titan and Enceladus are extremely interesting places. So there are. So let's put the question over to the viewers. Viewers, if you could devote, say, I don't know, a few $1 billion to exploring one place in the solar system, what would that place be? Where would your money go? So please put your answers in the chat. Let's see what you think, because you know, we all have our favourites really. And Barry says, actually talking about Saturn, he says, hang on, there we are. Saturn's dark side shouldn't look darker than the sky. Anybody want to pick that one up?
Where did that come from?
Yeah, I know.
I don't. What are you looking at that where Saturn's dark side?
It was the painting of Titan with Saturn in the sky.
Oh, the first image that Andy brought?
Right, with you now, Barry. With you.
Let's see.
Let's
I want to bring that up and
yeah. Do you want to hang on? Let's just bring that up. We'll have a look. Yes, what's going on with this image? Hang on. You'll have to go back to your first slide, Lou.
oh, okay, we can do it here this way.
Yeah. Let's just have a look.
Back.
Because this is actually a Cassini image. It's not an artist's impression. It's a real image from Cassini.
Right.
Here
we go. Okay.
There we are.
There we are.
Not that.
Is that the one?
I think it was that one. It was. It was. It was. Might have been your representation, Andy, with Dragonfly.
Oh, right.
In the sky over time.
Oh, right. Yes.
Uh,
I know. Sorry, Barry. I'm with you now. Yeah. No. I know exactly the.
Sorry, I didn't describe it.
Talking about. Yes, that's a illustration issue. Definitely, you're absolutely right. Of course.
Yeah.
So thank you for spotting that. So there we are. So anyway, yes, if you have a favorite place in the solar system you would definitely like to spend money exploring, then let us know in the chat. As Sandra already says, Pluto for me, I would have said Mars before, but there's already quite a lot of exploration happening and ongoing. Very true. We do need another mission back to Pluto, because don't forget, we only saw one hemisphere of Pluto. We saw the back of Pluto, if you like, the dark side, the night side, only very dimly. And as New Horizons was approaching Pluto, the other hemisphere appeared to have these regularly spaced dark spots across the equator of Pluto. And you know, what was that all about? And we don't know. We didn't get to see. So another mission to Pluto we'd all love to see. But of course, it takes so long to get there. We'll all be dead before it happens, I think. So, I mean,
Sandra, do you want to go to Pluto, or just send someone else?
Yeah, do you want to go to Pluto, Sandra? We'll have a wit round if you like, if you really want to go. Start a crowdfunding for you. So yeah, no, I think Sandra means, as I asked, spend the money on going to Pluto. So thank you for that. Anybody else got any preferred places to explore? Ian says, how about Ceres? The asteroids probably hold untold mysteries. Well, we already know that Ceres is more interesting than we thought, because it's strongly suspected of having a global underground ocean. So yes, worthy of investigation. Sandra says she would go to Pluto.
Hey!
So there we are. I've got a brave lady here.
Well, we would miss you, Sandra, because there's no internet. There's no
just wouldn't
YouTube.
be the same without you. It really wouldn't. And you'd have to pack your thermals and some thick boots, but you'll be fine. You'll be fine. So there we are. Okay. So, right. Any others? Anybody want to spend money anywhere else in the solar system exploration? Derek says Ceres was my other choice, although it's a lot closer. What was your first choice? Did I miss your first choice, Derek? Right. Okay. Got a few here. Kev says Europa or Enceladus. Well, we're about to be blessed with 2 missions arriving at in a few years. We've got 2 missions arriving at Europa. Like London buses, wait 5 hours and loads come at once. So there we are. And
I like Pauline's comments.
Right. Hang on, I can't see that. So there we are. Anyway, well, I think
that's the one.
Yes, indeed. Although, what worth would they have if you brought more back to Earth?
Yes.
Yeah. But diamonds are nice anyway. They're kind of pretty. So, Roger, what about you? If you had a few billion to spend, where would you explore? You're on mute. Or has your sound gone again?
Probably.
We really need to chip in for a good mic.
Yeah, we need to buy Roger a new mic.
Roger.
So can't hear you, Roger, I'm afraid. So anyway, we'll go over to Dave. Dave, where would you spend the money?
Oh boy, yeah, I'm tortured by this because the geophysicist in me really wants to go to Venus. On the other hand, having an unlimited budget, I think I would rather go out to the outer solar system. So I guess I would pick of all those Europa probably.
Right.
But they're all good choices. Let's go to all of them. I think so. I think we should do.
Yeah.
A grand tour.
Grand tour. Yeah, absolutely. Paul says it would be Titan for me, as so much is hidden from us. Love Mars, but same as Sandra says, I've seen quite a bit from the surface. Fair enough, Paul. Yeah, I think you've got some agreement here.
People are getting tired of Mars. Wow. What's going on here?
I think Elon Musk has done a lot to put people off the idea of Mars, to be quite honest. Yeah, but we are going to get there, with or without Elon. So there we are. Okay, anything else? Yeah, Sandra says she's got all her cold weather gear because she lives in Wales. Yeah, of course you have. Mind you, it has to be said, Wales is not a cold place. It's a wet, windy, Atlantic storm sort of place, but it's the climate.
She does live in North Wales, doesn't she? So
yeah, I mean, where I used to live in South Glamorgan, about a mile from the sea, it rarely snowed, but when it did, it was a lot. So we used to get dumped on every few years, and our whole village got cut off for 5 days once. And the council sent a snowplow out, and that got stuck. So they had to send another snowplow out to rescue the first one, and that one got stuck, and they gave up on that. Yeah, I had a whole week off work because we were completely cut off. It was great, fantastic. Okay, so Paul Shrum says it's just that Mars has had more money launched towards it so far than the other destinations. Time
Yeah.
to share the love. Totally agree, Paul. Totally.
Yeah.
Planetary socialist, I see. Okay. Even it out. Even
You
it out.
Americans see socialists everywhere.
We do. Yes. They are, you got to watch out for them. They're everywhere.
Socialists, it used to be Res under the bed, but now it's socialists under the bed. So there we are. Okay, Mike Beer says Cardiff is freezing today. Yeah, I'm sure actually. I've seen on the news. And Mars gets a vote from Ian. Ian says Mars has to be first, really, as it's so much closer, and there's a lot of science yet to do. Again, very true. It only takes 6 months.
And Venus has.
Sorry?
And Venus is so much closer as well.
Yeah, Venus is as well. But I did see that there's a new startup that are developing a new type of nuclear engine to get to Mars in 30 days. So that'll be interesting.
We will see.
Yeah.
Don't you have to slow down? Isn't that important?
No, you just aim for it basically. So there we are. All right then, let's move on, and we're going to go over now for our weekly look at the night sky and the viewers gallery, and it's going to be presented by a man who needs no introduction.
Oh, right. Can you hear me?
We'll get one.
Yes, we can hear you.
Yes, we can hear you now. Yes, great.
Oh, thank goodness for that. Okay, so we won't need the subtitles then. Thank you.
No, well, not more.
Right, so no. All right. No, I'm not a pirate. Not a pirate.
So you say.
So I say. Okay, so the 18th to the 24th of November. So we do have coming out to a new moon through Thursday. So that would be good. So a chance for some observations if you do get some clear skies. I think I've got some good skies for tomorrow and Thursday, but apart from that, it's going to be cold, wet, and windy, and snowy, and all those other wintry things. But as of 10 o'clock through this week, we do have the winter constellations coming up gradually more and more, and we some views of Saturn and the Great Sphere of Pegasus and Andromeda doing quite nicely, but we do have Jupiter coming out quite nicely as well. And we've also got our favorite constellation of Orion arriving, which is all the better for seeing. But shortly before sunrise, we've got Venus, and very closely before sunrise, we've also got Mercury. So no chance of seeing that for a little while. But following on behind, and not too long after sunset, we've also got Mars coming into view, but that will be more of a challenge with the brightening sun. So we've also got, as we speak, over the last night and tonight, we've got the peak of the Leonid meteor shower. So have a look for that. So we've also got the waning crescent moon, and we've also got Jupiter, Saturn, and Venus, and Mercury, although some of those will be a bit of a challenge with its nearness to the sun. So we've got the Leonids, which is debris from comet 55P Tempel-Tuttle. So I was out there last night, and I didn't see any at all, not one, but there is a possibility. If you look over towards the from the radiant point, which is coming from the east, so look away over to the south or wherever to try and capture any struggling meteors. They will be quite good to see, and with the moon waning quite severely, it's a good opportunity to spot those. So anytime really after it gets dark, really, but any chance is a chance. So try and prepare for the cold weather that we've got this week to get that opportunity, and send a picture in if you do. So we do have currently a 9% moon when that is happening, so it shouldn't be too bad to get anything from the washout of the moon glow. Oh, we've got Jupiter and Saturn, yes, we know that. And we've got Mercury and Venus in the morning sky, so they will be quite close to the sun, so it's not going to be too more of a chance for Venus than Mercury, actually. So, but we do have a conjunction later in the week, next week, so it won't be too bad to have an opportunity to try and gaze both of those. So we've got a micro new moon on the 20th, as opposed to a super moon. So it'll be at its furthest point away when we've got a new moon. So that makes a change. Not that anyone will be able to see it. And on the 21st, we've got Uranus at opposition. So that will make much of a difference due to its distance and its size from our point in the solar system. So anyway, a chance is a chance. And then we've got, on the same day, we've got the moon near the Pleiades. So that's a good photo opportunity for the gallery next week. Hint, hint. So we've also got the northern and southern Taurids. So they were earlier in the week, last week, but we got the northern Taurids just about finishing. So there is still a possibility for any meteors. So on to the gallery, and we do have a larger gallery than. Obviously, people were busy last week going through their images and managing to get out and about to take their pictures. And to start us off, we've got Kenneth Holmedal. And he's been using his Olympus equipment. And because of the results that he's been getting, he's selling some of his astro gear.
Oh, really?
Yes. Now, the first one was of the Orion Nebula, which he had with his 100 to 400 lens. Because it's a micro 4/3, it's like a 200 to 800 millimeter lens.
Blimey.
But you'll see why he's selling his equipment, because this is what he gets with
my goodness.
with his camera. Yeah.
That's amazing.
Mm.
That's beautiful, Kenneth.
Brilliant.
Well done.
Isn't that atmospheric?
Very. Lots of gassy details there as well. And
Well done, Kenneth.
when he wasn't doing that, he was doing this of the Pleiades, and this is just
Oh,
Ooh.
Beautiful. Beautiful.
wow.
yep.
I
Absolutely.
mean, that's just incredible. Look at the nebulosity. Look at the detail in it.
I know. And that's only an hour. You usually take about 5 or 6 or dozens of hours if your name's Tom.
If your name's God, if he were here, he'd be tearing his hair out.
Absolutely. Yeah, absolutely. Well done, Kenneth. And then we've got a few images from Kevin this week. And the first one is Ganymede. So this is on the 11th in
Wow.
good seeing, and a close-up look of Ganymede. And it was 1.5 arc seconds in diameter. And this is the first time he's managed to get some vague surface markings, for goodness sake.
Wow.
So this is what he's produced. So what was in the
Look at
Wingy
that.
Pulse simulation. So there is something there, isn't there?
I
Some-
think this is the first image we've ever had of Ganymede, isn't it, in the gallery?
Yes, I'm pretty sure.
Probably.
Yeah.
Yep.
That's amazing, Kev. With your C11.
Wow.
Incredible.
You would have thought that was possibly some colored images of Venus's cloud formations or something. But
Yeah.
that's one of
How
the
many Barlow-
yeah.
How many
Amazing.
Barlows do you have to stack to get that? That's,
Yeah.
I know. 1.5 arc seconds in diameter as well.
Yes.
So there you go.
Wow.
Yeah.
Well done. Good effort.
Yes, amazing. Right. So, Jupiter and Ganymede from Kevin. So this is what he's managed to get with the Great Red Spot. And some albedo features us also seen on Ganymede. Da-da-da.
Ooh.
how beautiful.
Oh, wow.
Yeah, that's nice. Lovely.
Very good. Well done, Kevin. Right. There we go. Right. Now we've got some lunar images from Kevin. And this is Plato and Mare Frigoris. through his C11 at prime focus. And so we've got the original image. The narrow cleft running down the middle of the valley is just visible in places. So there
Wow.
we go.
Oh, that's some nice detail.
Just how the Apollo astronauts were viewing it as they orbited. Lovely.
Beautiful.
Right
Well
now,
done, Kevin.
they're saying if we screw this up, we're going to land right about there.
Yeah.
Crash land.
Absolutely.
That's amazing.
Okay. And then we've also got one from Kevin of the Apennine Mountains and Hadley Rill, which was the Apollo 15 site.
Yes, indeed.
So he was just got the terminator in the right place to catch it. And the rill is about a mile wide.
Ooh.
Wow.
Wow.
So it's about halfway up on the right half of the thing, right by the mountains there. You can see the squiggly rill with the crater.
Yeah.
And Apollo 15 was just around the top part of the rill there.
Right.
On the
Wow.
on the bendy bit.
Ah.
It actually looks.
You think this is a video stack?
Probably, yes. Knowing Kevin, I would have thought so, yes. With a mono camera. So there we go. Wonderful.
Well done, Kev.
And then we've got the Clavius region. So another one which he's got with some of the craters down to about a mile in diameter.
Oh, very nice.
Very nice. There's no base there.
You took the words right out of my mouth.
Yeah.
No,
I
no
thought
monolith.
it's fake. There's
No.
no base there.
Yeah.
Oh, right.
Let's take his face.
Okay. Well done, Kevin.
Yeah,
And
Kev says
then
it
we've
was a
got...
video stack, yes.
Yeah. So we've got one back from Lee after a little while, and he's got the wind farm Milky Way, which was a year in the making, according to this. So he's always wanted to do the wind turbines with the Milky Way.
All right.
And fortunately, the foreground was taken when the clouds and never gave her an opportunity to complete it. So he managed to do it this year. So he's managed to combine the two, and this is what you've got.
Oh, brilliant.
That was worth waiting for, wasn't it?
Absolutely.
Yeah.
Well done, Lee.
How big is that wind turbine?
Yeah. So half the length of the Milky Way, look.
Yeah.
Yeah.
I like that. That's brilliant, that is.
Well done. Yay. And then we go on to Jerry, who's got the Pac-Man Nebula. This was just over 3 hours. Well done. With his C-Star S30. So there we go.
That's very nice.
Beautiful. Oh, color. Very nice.
Yeah. There we are. Who needs a S50 when you can do it with an S30?
Exactly.
Right. Okay, Lou. Here's your Crab Nebula with the S50 with an hour integration. So you didn't have to level the tripod. At least it didn't fall over.
I think they've had a software update. You don't have to do too much.
Okay.
Oh, that's nice.
And you got some good structure in that, Lou. Well done.
Well done, Lou. Lovely.
Thank you. I didn't do it. I just set it up and pushed a button.
Yeah. Like the rest of us. Okay. Well done, Lou. And then we've got Michael with the Aurora Australis.
He's still in Australia, of course.
Yes, he's there till February. So this was on his mobile phone.
Oh, wow.
Oh, look at that.
Nice. You see a little structure. There's a little vertical structure there. Is that right?
Yeah.
Yeah, it looks like it.
Slightly.
Looks like
Yeah.
a hint of something there. Well done.
Totally unfamiliar sky.
Yes, absolutely. Everything's upside down.
Yeah, even the aurora.
And then we've got Lou with his M42 Orion Nebula. So an hour of 10-second subs.
Oh, Lou.
That one turned out pretty
Yeah.
nice.
Yep,
Wow.
got a bit of the running man in the corner there. Well done.
Yeah, C-Star ought to be paying me to do these free advertising.
Okay. Yeah, send you a complimentary S30.
Well done, Lou.
70, thank you.
And the commit is trilogy of images. We've also got Jupiter with the C-Star as well. So
That's about
this
as
is what
good
you
as
can
you're
get.
gonna
This is what you can get with a C-Star. But at least you managed to get some of the belts.
Yeah.
And the red spot.
And the red spot. Yeah.
And the red spot as well. So yeah.
Excellent.
Galileo would have been pleased to have seen that.
Yeah. He would, bless his heart.
Okay, so this is the last one, and it's one of
You
mine.
have
Which
to
I
put
took-
that up after mine.
Oh, sorry,
I'll get you
sorry,
back to this,
sorry,
Roger.
but sorry, not sorry.
You will rule the day, my friend.
I know. So this was last night, and this was a shadow transit of Ganymede and with Europa as well on the C11 as well with a 2.5 times parallel.
Wow.
And this is what we've got.
Cool.
You can hardly see the difference between that one and Lou's.
Yeah, yeah,
Yes,
Yeah.
yeah.
Wow.
Where's your stupid red spot, Roger? Huh?
I got the dreaded black spot, which
That
is
my
the shadow of Ganymede going across there.
Wow,
Wow. Wow.
Yeah.
lovely.
Hopefully, I can try and see if I can get better seeing through maybe Wednesday or Thursday night, because it was a little bit in and out. So I don't think I cracked the focus quite as well as I did with Kevin's image. But there we go. But we're getting there. And that's what we have for the gallery this week.
Great. Thank you ever so much, Rod. That's absolutely wonderful. So thank you, viewers, for sending in your images. Hang on, just give me 1 second. My mouse is running away with it. Okay. So thank you so much for sending all of your images into the gallery. We do love looking at them. Don't forget, they will also appear in our galaxy. They will appear in our galaxy.
Yeah. Far away.
Yeah, but specifically on the sort of the outer fringes of one of the arms of the galaxy. And that being in the website gallery, https spaceoddities.space. All of the viewers' images are in the galaxy. In there. Should we try that again? In the gallery, every person has their own little gallery on the website, so you can show off your wonderful work to friends, family, and passers-by in the street. So there we are. And if you want to send images in, I'm sure you know the drill by now. Simply attach them to an email, 1 image per email, please, and address that email to gallery@spaceoddities.space. Gallery@spaceoddities.space. And we thank you so much. Nice to see some unusual images this week, especially of the southern aurora, the southern lights, and Caves Ganymede, which was spectacular. So there we are. So thank you all very, very much indeed. Keep them coming in because we love them. And there we are. All right. Now, as I said earlier, we're very pleased to welcome Dr. Dave Williams to within the enveloping fold of the Space Oddities community. And Dave, you are most welcome. We are so happy to have you on board with us. And we hope you're going to enjoy being with us. If not, tough luck. There's not much we can do about that. But you know, that's life. That's life. So just go over just before we talk about a couple of other things that you want to show us this evening. Do you want to sort of give us a brief history of your work in planetary science?
Oh yeah, sure. And thank you for having me. I was I was just completely surprised when I got invited to join you guys. It's a lot of fun, and so yeah, thank you. Yeah, I guess I grew up in New York, Long Island, about 40 miles from New York City. I went to undergraduate at Binghamton University in upstate New York, and then I went to graduate school at UCLA. After that, I worked as a postdoc at Arizona State for about 3.5 years, and then 2 years at the Carnegie Institution in Washington, D.C., and then I started working at Goddard Space Flight Center for NASA, which is where I've been up to just now, where I'm just retired. I won't go into it. I didn't really want to retire, but there's things are happening in the government right now, and it's people are getting pushed around a little bit. So I'm the reluctant retiree, as my friends call me now. But this is great. So I'm glad I have fun to do. Some ways to stay in this and work on this. At NASA, what I worked at the what was called the National Space Science Data Center, which was NASA's deep archive for all their spacecraft data, and actually the archive for all planetary, lunar, astrophysics, and space physics data from other countries as well. That slowly, while I was there, got split up because of various bureaucratic maneuvering, I guess. Basically, I'd have to say. So it's basically now what the data center is basically concentrated on the planetary and lunar data. The astrophysics now sort of has its own data place, and space physics has its own data facilities. But as that, I've been basically, at least part of my job has been responsible for the database, which is really a lot of fun, because it's basically the database of everything that's ever launched. And so I've been able to go and look at a lot of old missions and I update them. I've found a lot of new information. A lot of new information, of course, has come out about all the old Soviet missions, because at the time they couldn't get much, obviously, with the in the 60s, 70s, 80s. There was very little information about those, because of the Iron Curtain and all. They didn't give out much, but a lot of that now has come to light. So we know about a lot of missions that we didn't know about before. Missions that were planned, for example, to go to Venus or Mars and failed. So the Soviet Union would just name them a Cosmos mission, and they were in Earth orbit. That's what we always planned them to do. Then later on, found out that no, this was actually supposed to go to Venus, but it blew up in orbit or something failed, and it never made it. So all that's been just fascinating to me, and I guess that's part of why I've gotten interested in the history of all these various missions in spaceflight. And the other part of the job that's really I've loved is restoring a lot of the old data. I mean, we've got data going back to the 60s, and a lot of it's on old tapes, microfilm, microfiche, formats that no one uses anymore. And so to go back and be able to kind of restore these data and resurrect them and make them useful again, it's a lot of fun. It's kind of like a detective thing, trying to find out information about these data from 50 years ago is a challenge, but it's been a lot of fun. And we've managed to get a lot of data out there that was never really looked at, or was looked at very, very quickly and then kind of got archived away. And now we have lots more ability to look at these data. So it's a lot more fruitful, I guess, to be restoring some of these, to be able to look at them with the modern computers, modern data mining techniques, and AI now, really, I guess.
Yeah.
Yeah.
So I guess is the age-old question: is it what medium do you record data on for the future?
Right. It changes. So there's a big group now. Now that they really have done a lot to take this very seriously. That but I mean, back to the time, everything, put it on microfilm, it'll be safe forever, blah blah blah. Well, I mean, in a way, that's true, and I have some great stories about old microfilm. But it's not very user friendly, right? I mean, obviously. So what they're doing now is they are constantly looking at what media are available and what's coming up in the future, how long they think it's going to last, and just refreshing the data and put it on new media. Pretty much have a 10-year refresh schedule, so that anything that's been sitting on whatever media is for 10 years is now put onto either the same media if it's still something that's good, but for the most part now it's getting moved to something new. Right now, digital linear tape seems to be the media of choice. But that could change. And the thing that I really learned that's interesting, at least to me, and maybe not interesting to anyone else, I don't know, is that the media itself actually lasts way longer than people even thought. Even like digital magnetic tapes, those big reels of tapes.
Yeah.
It's the ability to read them. It's the equipment to read them. Because we were reading 7-track tapes for a long time while I was there, and we had a 7-track tape reader that we were babying along and just keeping running. But eventually something goes and there's no replacement part for it because no one's making them anymore, right? So you just can't, you just can't get it working again. And finally, that gave up the ghost. Our 9-track tape readers not too long ago gave up the ghost. Luckily, that data have they've been transferred to new media, and so those have all everything we had has been saved. But every once in a while, someone's coming up with something, in an archive somewhere else, or even in someone's like basement or just an office, and here's some old 9-track tapes or 7-track tapes. There are companies that will read those. About $100 a tape. So if someone's got a collection of a few hundred tapes or a few thousand tapes, it gets to be a problem. Someone comes across 2 or 3 tapes, we can try to, we have the resources to try to get those read and find out what's on them. But
in a sort of related thing, my old family holidays from when I was a child, my father filmed on standard 8 film with a cine camera. And he never had a Super 8, never had the one with sound, but it was all silent standard 8. And we were saying, repeatedly, we must get that transferred onto X. And first of all, it was VHS, and then no VHS. Apparently, these new CD-ROMs are good. And then they came and went, DVD, no, let's get to put that. We can get so much more on a Blu-ray disc now. And and nothing applies anymore. So.
That's exactly right. Really, it's a big effort to try to keep up with, what the technology and what they expect is going to be and how long things are going to last. And I think it's getting harder because I think things are changing even faster. Microfilm was around forever, and even 9-track tapes were around for a very long time. But now it seems like every few years, the next greatest thing is coming along, and if the other stuff gets abandoned before you get it moved to the new thing, it can be a problem. So,
Dave, I have a question. So, I haven't worked there in quite a while, but yes, I remember all the tape racks and the digital tape and the robotic tape access. But so you're largely planetary science now, maybe entirely planetary, right?
Pretty much, 90-something% planetary and lunar science. Yeah.
And NSSDCA is a deep archive. So would you consider migrating to the cloud?
We are. Yes. Yeah. It's not what we've looked into it a lot, and we've been told to look into it a lot. Right. It's as a deep archive, it's not our preferred. We're trying to avoid that. We right now have multiple copies of everything on tape, stored away, including at a facility called Iron Mountain, where it's stored away in a climate controlled warehouse. To give a geographic distance from Goddard, where we have our another set of everything, just in case something.
In case the comet hits.
Bad happened, and so that there's the things are separated geographically, and it's actually written into our our mission statement or whatever, that we do have to have a geographic separation between data sets or copies. So yeah, I mean, we let's see. Well, I mean, I guess that's really it. We just keep multiple copies on whatever the latest media is. And I don't know. Was there another part of your question? There wasn't there? I forgot what it was. Sorry.
Your compatriots in Earth science, both at NASA and NOAA,
They're using the cloud a lot. Oh yeah, that's right. Boy, I got off track. Sorry about that. Okay. Anyway,
I think for the PDS, for the active archives where you get your data from, that they're probably the biggest holdouts in the astronomy, space science, earth science community, don't you think?
And some in the planetary data system, and the way the planetary data system is set up for everyone else is there are nodes. There's an atmospheres node, there's a geology and geophysics node, there's a small bodies node, there's and they each specialize in their own thing. And they're at different places. So there's one at the University of Maryland, for example, and there's one at Ames Research Center, and they're spread around. But some of them have gone more into the cloud than others. It's been kind of an individual decision for them. The reason for one thing, we're really worried about the expense. And the problem with the cloud, if you're storing very large data sets, is most of the cloud, it's private. It's Amazon, for example, or whatever. It's private companies.
Mm-hmm.
They could easily, at any point, change their and it's written into the contract. I think they can change their model basically, and then they could all of a sudden charge some outrageous price for you to pull the data back out, and you'd be stuck. I mean, no one's done this yet, but you can always imagine it could be possible. But the other thing is that we talk about an air gap basically, and in other words, having data on a tape stored away somewhere, no one can get to it, no one can mess with it. There's always a fear that someone will, I don't know, hack into the cloud, right? And all of a sudden your data is completely corrupted or messed up. So to me, that's a pretty big, if I'm going to have a deep archive, I feel like I want at least one set of these data to be somewhere where they're not online where someone could get to them. They're just somewhere where if something happens, we can pull out the tape and read it again, and we know that these data are not corrupted. They're just they've been sitting aside. So I guess philosophically, that's my main objection to the cloud. Is it scares me a little bit that data is accessible kind of to a bad actor possibly.
Mm-hmm.
But yeah.
Okay, well, thank you for that, Dave. All very interesting. And anything else you want to add to that before we move on?
No.
Okay.
That's
all right.
That's pretty much what I do. Yep.
I think we're going to change the order slightly because Dave, you went out and come back in again, which means you have to re-upload your PDF. Yeah, because if you exit the studio, your PDF goes with you. So can you remember how to do that? We're teaching Dave. This is his first time on Space Oddities, so we need to sort of give him a bit of tuition. So please bear with us, viewers. If you can remember how to do that, I think we'll go to Constellation of the Week next. Are you all right doing that, Dave?
I'm not sure because I was having so many problems. My laptop, basically, I had to bail out of my laptop because I've gotten these issues with battery that I was talking to you about earlier. And I'm on my phone. Now I'm talking to you from my phone. Lou, I think you have a copy of it.
You sent me a copy?
Yeah, of the PDF.
Did you send it by excuse us while we do.
I emailed it to you. I'm sorry.
Did you send it by email?
Yes.
Okay, well, what we'll do then, we'll go over to Roger for Constellation of the Week while you two gentlemen try and sort that one out. Okay.
Right. Sorry about that.
Okay. Roger, are you ready? Roger? Hello, Roger. Earth calling Roger.
Let me see, maybe.
Okay. Well, what we'll do, ladies and gentlemen, we'll go straight to the perils of live broadcasting. What we'll do
Save
then?
us, Andy.
Sorry?
Save us.
Yeah, okay, I'm going to save you. What we're going to do now, we're going to go over to Einstein of the Week, our weekly delve into the wacky world of social media. So just give me a second, and have you got it? No, don't worry. Don't worry. Okay, we'll move on. And let's go over to our weekly look at the insanities of social media. And here we are. So I've just got a few Einstein of the Week for you. And the first one I've called Who Needs Daylight? And this was quite fun. And this gentleman said the moon has been given a huge importance and significance in our religion because moon shines light at the night when we need it, not like sun, which shines at the day. Who needs light at daytime? Once again, it's proved that our religion is the most intelligent one. Well, just speaking personally, I kind of like light during the day. Not much use at night, unless you're an astronomer, of course. But anyway, thought that quite typically that somebody could say that.
Brilliant.
Yeah. Who needs light during the day anyway? It's completely wasted. So there we are. The next Einstein of the week. I bet astronomers wish they'd thought of that. Question from somebody on social media. Can't we determine a star's character through spectroscopy by studying its key elements and what makes up the star, such as light and heat? Amazing idea. Amazing idea. And but did point out to him that spectroscopy is in fact quite an important way of observing stars. But I was quite just surprised that he'd not heard of that. But considering he didn't know that astronomers use spectroscopy, I think it was a good suggestion. So perhaps we shouldn't be laughing so much. The next one, I just want to bring you a conversation I had with somebody on social media, because this did make me laugh. We've had this conversation over the last couple of days on Facebook. And it started off with this guy called Al Cole posting a photo from Mars, from the Curiosity rover, of basically a rocky outcrop on Mars. And I replied, it's just a pile of rocks, obviously. But he said it's an ancient city on Mars now. And I just said, it's a pile of rocks. So the conversation went on. He replied, maybe now, but that looks like maybe an ancient city on Mars. And that's an obviously landing craft on that landing pad, and looks like doors and windows in that building. And there are other smaller buildings there as well. To which I replied, your imagination is running away with you. I've looked up the scale of that image. The rectangular blocks are between 0.5 and 1 meter long. Are we talking really tiny Martians? Now, you would think that would have been the end of the conversation. Are we talking really tiny Martians? But to my surprise, the answer was yes. I think they're much smaller, maybe around a foot high. The gravity is around 38% less than Earth, and people are way smaller than us humans, so probably the buildings are much smaller. So we are talking really tiny Martians. Brilliant. And then he went on to say, there are many other races out there, but I think us humans maybe originally emigrated from Mars after their massive war. Look up Martian Genesis on Facebook. Lots of pictures there. If you don't know about this, Martian Genesis is it's like the creationist answers in Genesis. It's just full of complete lies and nonsense. And they put forward this idea that the Martians were two nations who had a massive nuclear war on Mars, even though there's absolutely no sign that there ever was a nuclear war on Mars. And the survivors emigrated to Earth. But what's bothering me about this is if they were only a foot tall, he said somewhere else in the post that humans are descended from those foot-high Martians. So I'm just trying to work out how that works. So anyway, this was doing my head in, but I just thought I'd share that with you because.
Wait, is Danny DeVito a Martian?
You didn't know? Yes, apparently so. So there we are. So really tiny Martians this week. And I just thought I'd share that with you because it did make me laugh. And lastly, if I didn't have that many this week, lastly, there's a Facebook page called Engineering Fact. And we have to put the word fact in inverted commas there because this was their latest announcement. CERN scientists claim communication with 3I Atlas objects, leaving experts worldwide stunned and deeply concerned. So CERN scientists have been communicating with the comet, apparently. Yeah, and you know, the nonsense about the comet goes on. In case anybody was wondering, by the way, the comet is alive and well, as I said earlier, and getting closer to the Earth now. So it's JUICE, isn't it? The Jupiter Icy Moons Explorer is going to get the best view of it. And we should get a lot more data about the comet over the coming weeks and months. So stay tuned. We'll bring it all to you here on Space Oddities, obviously.
I wonder why CERN scientists.
I don't know. I don't know.
This is the Large Hadron Collider, right?
Yeah, it's just yes, really, really weird. But there you are. That's Einstein of the week. Bit of fun for the week for you. So Dave and Lou, our two Americans are having trouble getting it together, which will come as no surprise to anybody. So we love you, really, honestly.
We don't need your pity.
I think you do. Look at your president. So yeah, it looks like you're ready. So anyway, Dave, this day in.
I uploaded, so I think I have to change the slides, maybe.
Okay, if you could do that, Lou. Thank you. All right. So just really quick, right? When you asked me to do this, I thought this was something that I had done for our, just because I was, involved with basically the history of all these different missions and stuff. So I decided it would be fun just to put on our webpage at the data center a thing that would just update it every day, and I compiled about 1,000 different things that happened over decades, and actually even some go back centuries of just interesting stuff that happened on any given date, and then it would just pop those up. And so I just thought, if you were interested, and it sounded like you are, that I would do this. I'll do this each month or each week rather, when we do this show. I'll just say, here's what happened on today's date. So here's for November 18th. Here's a couple of things that happened. So go ahead, Lou, if you can do it. And then I obviously need to learn a little bit more about the formatting. You guys have all these great fancy slides, and these aren't. But okay. Anyway, so in 1961, Ranger 2, obviously the second of the Ranger spacecraft, launched. It was, you see the picture there. It was about 4 meters high, 300 kilograms. It was actually not launched to the moon, which I guess I should start out by saying this was what the Rangers did. For if anyone doesn't know that, they were just basically designed to. They were going to launch them at the moon, and they were just going to take pictures all the way down until they crashed on the surface. And this was really the first sort of research part, I guess, of the Apollo program. The idea was, okay, now we're going to get some close-up pictures of the moon, get an idea of what the surface looks like as our first step in trying to get ready to bring people to the moon. So this one was actually just a test mission. They put a whole bunch of space physics, magnetometers and particle detectors on it, and they launched it. The idea was to launch it out into deep space and just test out all the systems and stuff, and bring back some data in the process. Unfortunately, one of the gyros failed, and they couldn't orient it correctly, so they could never fire the Agena final stage to put it into its final Earth orbit, and then put it into its sort of deep space trajectory. And so it ended up going into a very decaying Earth orbit, and ended up just coming back into the atmosphere the next day. Well, okay, so you can see at the bottom there, this was the second of 6 successive failures of Ranger to perform what they wanted it to do. And And I still think this is amazing. I do not know of any other project in the history of any country's space program where they had 6 successive failures and kept going. And yet they did. And Ranger 7, 8, and 9 were all successful. And and you've probably seen the beautiful pictures as the thing just goes hurtling down towards the surface, just constantly just sending back pictures until it crashed. And so, it ended up being successful, very successful, although by the time it was the 6th, Ranger 6 actually worked all the way, was hurtling down towards the surface of the moon, and the camera never turned on. So they were a little closer each time. But in any case, so it's a very interesting. It was almost the end of JPL actually as an arm of NASA because of all these failures of the Ranger missions. But they did finally succeed, and so this was.
You think about it, Dave. People were really having a dig at SpaceX because of 3 consecutive Starship failures.
Yes.
And in those days, it was the attitude, I think, was just sort of, oh, never mind, you'll get it next time. And,
yes, it was. Although 6 times was crazy, but you're right. There was so much emphasis on Apollo getting people to the moon that they really, they just said, well, look, we're going to keep going. Cost wasn't so much, and I guess I have to say this was before the time where failure is not an option. That wasn't a thing then, I guess.
Yeah.
Obviously.
Sorry.
Right. So anyway, but it's it's a very, very interesting history, and so I imagine with 9 launches, I'll probably be talking about more Ranger launches in the future if they're on the right dates.
Yeah, and as Barry said, it was amazing that they landed on the moon only 8 years later. So
no, it's absolutely amazing. I mean, when you think about it, what that kind of a push can do. Having those resources, that amount of money, and that kind of a push. Yeah. But also, yes, yeah. I mean, just the determination to do this was quite remarkable.
Yeah, those were the days.
Yeah. Like I was saying before, right? It's good fun to go to all these planets. If we could have done that if we had the equivalent of an Apollo program, probably. Well, anyway, okay, so go ahead. Sorry.
We've got these, this sort of vacuum of a few years without planetary mission launches, and coming up, and it's very sad because it could so easily have been otherwise.
It's a killer, but I know so many people that I worked with at NASA who basically are leaving just because they have nothing to do. They don't want to sit around for 4 or 5 years and wait to see if and of course you need such a huge lead time for these missions. You can't just it's not like in a few years maybe we're going to start up and go to missions, build missions again, like okay, that's great, but the mission's not going to be built or fly or do anything for another 5 to 10 years. So
exactly.
It's tough. It's going to hurt. It's going to hurt in the future. It's going to hurt a lot, and it bothers me. It's terrifying.
But on the other hand, if there is a glimmer of light at the end of the tunnel, which isn't an oncoming train, it's good to see other countries like UAE exploring Mars, and of course China and developing nations getting more involved with space exploration. So
absolutely,
So there is that.
Yeah, it's always been exciting to me when I'm working on opening up a record in the database for a new mission. And there's an ESA mission or a mission from India or a mission from Japan or China. It's always exciting. It's always been exciting for me to do that, and it's fun because you find out that their missions they're done differently, and so you get different kinds of information and stuff, and that's always been interesting for me too.
I mean India. sorry, I was just going to say,
Yeah.
India in particular, they're doing incredibly well considering their budget is absolutely tiny and their launches are so infrequent because of that.
Right.
But they are still achieving incredible things in space that would have been unthinkable just a few years ago.
Yeah, and it's great, and you can see that if you watch the launches and stuff and the landings or the going to orbit or whatever they do in India. They stream it or they televise it, and you can see the pride that they usually have the Prime Minister of India. They have the high level people all making speeches and everything when they do this, and I think it's great. Yeah, it's wonderful. Okay, so so next slide, Lou.
Mhm.
This is sort of the other November 18th event was the launch of MAVEN, Mars orbiter. So I don't know, you may have even talked about MAVEN here at some point.
Yeah,
but
we've talked about it a little bit. Yeah.
Yeah, it's a fantastic mission. Also, it reached Mars on September 21st, 2014. And it's just been orbiting ever since. It's been studying basically the Martian upper atmosphere and its interaction with the solar wind, with the space environment. And their main goal of the mission was to try to discover what happened to the Martian atmosphere. And then they seem to have basically confirmed the idea, which was fairly well known, that with Mars having no real magnetic field, no global magnetic field at least, is unprotected from the solar wind. And so the solar wind over billions of years has been just stripping the atmosphere away from Mars. And so that's why it's got 1/100th of Earth's atmosphere there. But the mission's continuing. It's still returning. It's still working perfectly well. It's returning data. It's costing the average U.S. taxpayer right now 4 cents a year. I only added that in because that was a mission that was in danger of being canceled as a cost saving.
Oh, goodness.
And we're talking about spending, I don't know how many $100 million it cost. I should have looked that up before I talk here, but a lot. Some $500 million or something at least in these missions. And they're talking about, there's a bunch of missions like this. They're talking about shutting them down. And I've just calculated how much they were costing. And, the total, there were 9 missions that were being slated to possibly shut down that were all operational, functioning perfectly. And the total for all 9 missions was costing the average U.S. taxpayer 22 cents a year.
No way.
Yes. Yeah. That's how absurd. I mean, I cannot think of a worse way to save money than probably canceling an active working mission.
No.
It makes no sense. So,
heartbreaking.
yeah. So I stuck a little dig in there at the end, but
yeah, goodness me. Right. Well, anyway, thank you so much, Dave. And
yes, thank you. Thanks.
And just to answer somebody's question earlier, yes, Dave is going to be joining us as a new. We'll put permanent in inverted commas because nothing in life is permanent. So we'll just have to see how it goes. But at the moment, Dave is a new member of Space Oddities, and he will be doing more this day in. And I see in the comments, Dave, you've got some. Hang on, just let me scroll up and find out where it was. Oh God, can't find it now. Can't find it. Never mind. I'm sure it was down here somewhere. Oh yes, no, here it is. Paul says. This day in space is a nice idea, thanks. Mm-hmm. And Ian says, I second that. So yes, so it's appreciated. Thank you so much.
No, thank you. No, it's been so much fun doing that over the years. Because I stumble across some weird fact. There's a lot of offbeat things in there too. So it won't just be rocket launches. Happen to be launches today.
But what I find difficult about your explanation of the MAVEN mission, And frankly, I don't quite believe it, Dave, to be quite honest, that it was 11 years ago since Maven launched. I just can't, I can't comprehend that. It seems like it was yesterday. It's my goodness me, unbelievable. But there we are. That's life. All right then. So Roger, are you okay now for COTW?
I am.
Okay. So we're going to go over to Roger now for Constellation of the Week, our weekly look at, believe it or not, a constellation of the week. So there we are, Roger. Take it away.
Right. It's another one of those 12 constellations that we don't mention about. So it's it's Capricornus, the sea goat. So there we go.
As if there is such a thing.
Yeah. So it's the smallest zodiac sign.
Oh, is it?
And yes. And it covers it's the 40th in size, so it's roughly halfway down the leaderboard. And it's a mythical half goat and half fish creature. And there's only one star brighter than magnitude 3. So it's not exactly a bright constellation. So we seem to have quite a few constellations like that, like we had last week. But there we go.
Yeah.
So it's a tale behind the sea goat. So it's Pan's transformation, who was the Greek god who was transformed into a sea goat whilst fleeing monstrous Typhon, creating an eternal reminder of the divine metamorphosis. There we are. Or in the Babylonian wisdom, we've got a link to the constellation to Enki, god of water and wisdom. So that's another water-based theme there. And the goat-fish hybrid represents sacrifice and renewal, seamlessly blending earth and sea elements into the celestial harmony.
Fantastic.
Well, there we go. So it's best visible in September, although it is currently available to see in the southern horizon. It's quite a low down constellation, so if you're not aware of it, you might need a little app to help you pick out where the stars are for that constellation due to its lack of bright stars. But it's bordered by Aquarius, Sagittarius, Microscopium. Oh, that's one from Michael.
Yeah.
Pisces, Austrinus, and Aquila.
Okay.
So there we go. So if you draw a line from Vega through Altair, two of the winter-summer triangles, it will go down to Capricornus near the horizon. So that's one way to have a spotting of it. So there we are. I've just highlighted it in here, so you can obviously see it between Aquarius and Sagittarius. So you can actually see how low it is to the horizon. So not one that's too good if you haven't got a good southern horizon.
Yeah. There we are.
But the brightest star, Deneb al-Gedi, that sounds very Arabic. Magnitude 2.85, and it's only the only brighter than 3 magnitudes, and it's only 39 light years away. So it has got an eclipse in binary system, and the Arabic name means tail of the kid, marking the position of the goat's tail in its traditional star lore.
Fair enough.
Fair enough. So just marked out a little constellation here with some Alpha and Beta Capricorni. So it is a naked-eyed double star of a yellow giant and a supergiant, easily split without optical aid. So it might be a bit like Miser and Alcor in
I was going to say. Yeah.
So we've also got Beta Capricorni, which is Dabi. Another yellow paired blue-white comparison star, so it might be worth having a little look-see through that at some point. All being good. And we've also got a white giant Nashira, which is Gamma Capricorni, which is 139 light years away. And we have got several confirmed exoplanets are in the in the area as well around Fomalhaut, which is not in.
Because one of those, and I think it was Fomalhaut B, was later demonstrated not to be an exoplanet, but a concentration of dust.
All right.
So there you are.
So there we go. There we are. But we do have a Messier object, M30, which is a globular cluster located 27,000 light years away and is at magnitude 7.5. So not too difficult to spot through a small telescope or binoculars, providing you've got a darkish sky.
Of course.
And it's moving towards us. So we may be pulling it towards us under our own gravity there. A couple of other interesting ones. We've got one from the Hickson Compact Group 87. But these are obviously things that you would need to photograph something in the region of a Hubble telescope or something like that. So out of our little pockets, and definitely not quite a C-star object. And then we've got Palomar 12, which is another globular cluster associated with Capricornus in the catalogue there as well. So a couple of interesting objects there, although out of our league, I'm afraid. But we've got 5 meteor showers linked to Capricornus. So that's quite interesting. 5, not 1, but 5.
Yeah.
So the Alpha Capricornids peak in late July, and they can be quite bright fireballs. So that might be worth a look at. So quite an interesting idea that we've got a small constellation, but we've got 5 radiant points coming from that area for those sorts of things. Do I need to go on with the astrology version of what? No. So we'll swiftly, shall we? Unless anyone has got a birthday at the end or beginning of the year that becomes your star sign. So the scapegoat ritual, that's connecting Leviticus's Day of Atonement. More biblical things, is it?
Yeah.
And themes of sacrifice and resurrection as well. Oh my goodness.
Oh, goodness.
So sounds a bit like paganism to me, but there we go.
Yeah.
So little fact here, just to say why we don't always have the constellations matching when the dates are. It's obviously due to the rotational period that the Earth does in relation to the night sky. So it's astrological 2,000 years ago it was in a different place, so that's probably why it was where it was during that time when it was labeled as that astrological position. So
right. There we are. Yeah. And this means, of course, that all of the astrology star signs are basically not right. So if you think you're a Libra and you're actually a Virgo, and so on, because there are now 13 signs of the zodiac, not 12.
Yeah, which is a Fucus, isn't it?
Yeah, it is. Yeah. So basically, astrology, as we well know, is a load of nonsense.
Yeah.
So
won't Vega be somewhere near a polar star at some thousands of years' time?
Yes, indeed.
That's correct.
Yeah, that's right. That's right.
So that'd be interesting.
Yeah, absolutely. So there we are.
Okay.
So thank you,
Right.
Roger. That was and fascinating. Michael, are you going to do Constellation of the Week next week?
I am.
Yeah, I think I've given them a clue what to do for next week.
Yeah, I was thinking of something else actually.
A southern constellation.
I don't think we've done Cepheus, have we?
Doesn't ring a bell. We can look on the cloud.
You can have a look on what's been uploaded anyway.
Yeah, I couldn't see it on there, so I thought I thought because that's still a northern constellation, you see.
Hang on a minute. Isn't Cepheus quite a large constellation?
Not too large.
Is it?
Oh, it's
Yeah.
green.
Yeah. Yeah. Oh, okay. Well, that's good that you're finally
I can do that next week. No
finally
problem.
thinking of bigger things. So
Yeah.
there we are.
Mm.
I don't have to do small ones.
Mm.
Barry says calling astrology nonsense gives nonsense a bad name. Couldn't agree more. Barry. Couldn't agree more. And Ian says
That's double negative.
a suggestion from Ian.
Oh, crooks, yes.
Yeah,
I've actually seen crooks.
I bet you have.
Yeah.
Yeah. So excellent. Thank you for that, Ian. Good suggestion. So there we are. All right then. Well, I think it's time to just draw things to a gentle close for this evening, viewers. We'd like to thank you all for being here. We'd like to thank and congratulate Dave on his first official appearance as a Space Oddity. Hope you've enjoyed yourself, Dave. Hope it wasn't too stressful for you. And there were some other comments about your presentation. If I can find that. Yo, Stuart just said more like that, please.
Yeah.
So there we are. So more like that, please, Dave.
Thank you.
And we hope we'll see you next week. And if we don't, we want a note from your mother. So there we are. That's in the contract too, by the way, as well as the joining fee, which we have to talk to you about. Yeah. So there we are. Anyway, it's been a lovely evening. Thank you so much for being here. We hope you all have a fantastic week. Can't believe these Tuesdays are flying by so quickly, but that's life. Christmas will be upon us before we even know it.
Yes.
I know Christmas is here because last week my daughter put the Christmas tree up. So
No.
yeah, I know. There's no getting away from it now, I'm afraid.
I've actually ordered a new Christmas tree.
Have you?
Yes.
Real one or an artificial one?
Oh, an artificial one.
Right.
No, right.
Yeah. Okay. Well, I'm surrounded by forest here, so it'd be very easy for us to just go out and take it. I can't be bothered, to be quite honest. But our dog, who is only 9 months old, is doing her very best to wreck the Christmas tree, as you can imagine. So there we are.
That's
All right then. Putting Christmas aside, we hope to see you back here next week, viewers. So from all of us at Space Oddities, look after each other. Have a fantastic week, and we'll see you back here on Tuesday. Just a quick word that Paul has mentioned on NASA TV tomorrow at, I think he said 8 p.m. UK. NASA are probably going to be releasing the images of Comet 3i Atlas that they couldn't because of the government shutdown. So new images of Comet 3i Atlas tomorrow. That's on YouTube. You can find NASA TV on YouTube easily enough. And we hope to see some great new images of the comet tomorrow. So thank you for telling us about that, Paul. Much appreciated. We'll see you all next week, viewers. Take care. And from all of us at Space Oddities, have a great week and goodbye.